underlines. But how will you explain this? How will you respond to this? So first thing, obviously, we will say that random forest is one of the algorithms, and the more important thing that you need to, probably the interviewer is waiting to hear, is ensemble learner, right? So this is one type of ensemble learner. What is ensemble learner? Ensemble learner is like a combination of algorithms. So it is a learner which consists of more than one algorithm or more than one maybe models. Okay, so in case of random forest, the algorithm is the same, but instead of using one instance of it, we use multiple instances of it, and we use. So in a way, that is a random forest is an ensemble learner. There are other types of ensemble learners where we have, like, we use different algorithms itself. So you have one maybe logistic regression and a decision tree combined together, and so on and so forth. Or there are other ways, like for example, splitting the data in a certain way and so on. So that's all about ensemble. We will not go into that, but random forest itself, I think the interviewer will be happy to hear this word ensemble learner. And so then you go and explain how the random forest works. So if the random forest is used for classification, then we use what is known as a voting mechanism. So basically, how does it work? Let's say your random forest consists of 100 trees, okay, and each observation you pass through this forest, and each observation, let's say it is a classification problem, binary classification 0 or 1, and you have 100 trees. Now if 90 trees say that it is a 0 and 10 of the trees say it is a 1, you take the majority. You may take a vote, and since 90 of them are saying 0, you classify this as 0. Then you take the next observation and so on. So that is the way random forest works for classification. If it is a regression problem, it's somewhat similar, but only thing is, instead of vote, what we will do is, so in regression, remember what happens? You actually calculate a value, right? So for example, you're using regression to predict the temperature, and you have 100 trees, and each tree obviously will probably predict a different value of the temperature. They may be close to each other, but they may not be exactly the same value. So these 100 trees. So how do you now find the actual value, the output for the entire forest, right? So you have outputs of individual trees which are a part of this forest, but then you need to find the final output of the forest itself. So how do you do that? So in case of regression, you take like an average or the mean of all the 100 trees, right? So this is also a way of reducing the error. So maybe if you have only one tree, and if that one tree makes an error, it is basically 100% wrong or 100% right? But if you have, on the other hand, if you have a bunch of trees, you are basically mitigating that error, reducing that error. Okay, so that is the way random forest works. So the next question is, considering the long list of machine learning algorithms, how will you decide on which one to use? So once again, here there is no way to outright say that this is the algorithm that we will use for a given data set. This is a very good question, but then the response has to be like, again, there will not be a one size fits all. So we need to, first of all, you can probably shorten the list in terms of by saying, okay, whether it is a classification problem or it is a regression problem. To that extent, you can probably shorten the list, because you don't have to use all of them. If it is a classification problem, you only can pick from the classification algorithms, right? So for example, if it is a classification, you cannot use linear regression algorithm there. Or if it is a regression problem, you cannot use SVM, or maybe no, you can use SVM, but maybe a logistic regression, right? So to that extent, you can probably shorten the list, but still you will not be able to 100% decide on saying that this is the exact algorithm that I'm going to use. So the way to go about is, you choose a few algorithms based on what the problem is. You try out your data, you train some models of these algorithms, check which one gives you the lowest error or the highest accuracy, and based on that, you choose that particular algorithm. Okay. All right. Then there can be questions around bias and variance. So the question can be, what is bias and variance in machine learning? So you just need to give out a definition for each of these. For example, bias in machine learning, it occurs when the predicted values are far away from the actual value. So that is a bias. Okay. And whereas they are all the values are probably, they are far off, but they are very near to each other though. The predicted values are close to each other, right? While they are far off from the actual value, but they are close to each other. You see the difference? So that is bias. And then the other part is your variance. Now variance is when the predicted values are all over the place, right? So if the variance is high, that means it may be close to the target, but it is kind of very scattered. So the predicted values are not close to each other, right? In case of bias, the predicted values are close to each other, but they are not close to the target. But here they may be close to the target, but they may not be close to each other. So they are a little bit more scattered. So that is what in case of a variance. Okay, then the next question is about, again, related to bias and variance. What is the trade-off between bias and variance? Yes, I think this is an interesting question because these two are heading in different directions. So for example, if you try to minimize the bias, variance will keep going high. And if you try to minimize the variance, bias will keep going high. And there is no way you can minimize both of them. So you need to have a trade-off saying that, okay, this is the level at which I will have my bias and this is the level at which I will have variance. So the trade-off is that pretty much that you decide what is the level you will tolerate for your bias and what is the level you will tolerate for variance, and a combination of these two in such a way that your final results are not way off. And having a trade-off will ensure that the results are consistent, right? So that is basically the output is consistent, and which means that they are close to each other, and they are also accurate, which that means they are as close to the target as possible, right? So if either of these is high, then one of them will go off the track. Define precision and recall. Now again, here I think it would be best to draw a diagram and take the confusion matrix, and it is very simple. The definition is like a formula. Your precision is true positive by true positive plus false positive, and your recall is true positive by true positive plus false negative. Okay, so that's, you can just show it in a mathematical way. That's pretty much that can be shown. That's the easiest way to define. So the next question can be about decision tree. What is decision tree pruning and why is it? So basically, decision trees are really simple to implement and understand, but one of the drawbacks of decision trees is that it can become highly complicated as it grows, right? And the rules and the conditions can become very complicated, and this can also lead to overfitting, which is basically that during training you will get 100% accuracy, but when you're doing testing you will get a lot of errors. So that is the reason pruning needs to be done. So the purpose or the reason for doing decision tree pruning is to reduce overfitting or to cut down on overfitting. And what is decision tree pruning? It is basically that you reduce the number of branches, because as you may be aware, a tree consists of the root node, and then there are several internal nodes, and then you have the leaf nodes. Now if there are too many of these internal nodes, that is when you face the problem of overfitting, and pruning is the process of reducing those internal nodes. Alright, so the next question can be, what is logistic regression? So basically, logistic regression is one of the techniques used for performing classification, especially binary classification. Now, there is something special about logistic regression, and there are a couple of things you need to be careful about. First of all, the name is a little confusing. It is called logistic regression, but it is used for classification. So this can be sometimes confusing. So you need to probably clarify that to the interviewer if it's really, if it is required. And they can also ask this like a trick question, right? So that is one part. Second thing is, the term logistic has nothing to do with the usual logistics that we talk about, but it is derived from log. So that the mathematical derivation involves log, and therefore the name logistic regression. So what is logistic regression and how is it used? So logistic regression is used for binary classification, and the output of a logistic regression is either a 0 or a 1, and it varies. So it's basically, it calculates a probability between 0 and 1, and we can set a threshold that can vary. Typically it is 0.5. So any value above 0.5 is considered as 1, and if the probability is below 0.5, it it is considered as 0. So that is the way we calculate the probability, or the system calculates the probability, and based on the threshold it sets a value of 0 or 1, which is like a binary classification, 0 or 1. Okay, then we have a question around k nearest neighbor algorithm. So explain k nearest neighbor algorithm. So first of all, what is a k nearest neighbor algorithm? This is a classification algorithm. So that is the first thing we need to mention. And we also need to mention that the k is a number. It is an integer. And this is variable, and we can define what the value of k should be. It can be 2, 3, 5, 7, and usually it is an odd number. So that is something we need to mention. Technically, it can be even number also, but then typically it would be odd number, and we will see why that is. Okay. So based on that, we need to classify objects. Okay, we need to classify objects. So again, it will be very helpful to draw a diagram. If you're explaining, I think that will be the best way. So draw some diagram like this, and let's say we have 3 clusters or 3 classes existing, and now you want to find for a new item that has come, you want to find out which class this belongs to, right? So you go about, as the name suggests, you go about finding the nearest neighbors, right? The points which are closest to this, and how many of them you will find, that is what is defined by k. Now let's say our initial value of k was 5. Okay? So you will find the 5 nearest data points. So in this case, as it is illustrated, these are the 5 nearest data points. But then all 5 do not belong to the same class or cluster. So there are one belonging to this cluster 1, the second one belonging to this cluster 2, 3 of them belonging to this third cluster. Okay. So how do you decide? That's exactly the reason we should, as much as possible, try to assign an odd number so that it becomes easier to assign this. So in this case, you see that the majority, actually, if there are multiple classes, then you go with the majority. So since 3 of these items belong to this class, we assign, which is basically the, in this case, the green or the tennis or the third cluster, as I was talking about. Right, so we assign it to this third class. So in this case, it is that's how it is decided. Okay, so k nearest neighbor. So first thing is to identify the number of neighbors that are mentioned as k. So in this case, it is k is equal to 5. So we find the 5 nearest points, and then find out of these 5 which class has the maximum number in that. Okay, and then the new data point is assigned to that class. Okay, so that's pretty much how k nearest neighbors work.
Today, we are going to talk about some of the essential programming interview questions for a data scientist role. Now, since Python is widely used programming language for data science, machine learning, and deep learning, we will be solving our problems in the Python programming language using Jupyter Notebook. So let's begin with our first question. Our first question is, how do you get a list of all the keys in a dictionary? Now in Python for data science, data structures play an important role to store and manipulate data. Dictionary is one such data structure that is declared using curly braces, and they are written as key value pairs. You can see on the screen I have my dictionary called D, and it is assigned using curly braces. Now to get a list of all the keys in a dictionary, we use the .keys function. Now let me take you to my Jupyter Notebook. So here is my Jupyter Notebook, and you can see my first cell. I have my dictionary defined. So the name of the dictionary is D, and it has the key values. The keys are the country names, and the values are the capitals of each country. So I have India, and the capital is New Delhi. Then I have USA, the capital is Washington. Similarly, I have Spain, Madrid, and we have Germany and Berlin. Now India, USA, France, Spain, all these are my keys. So to get the keys, I'll use the .keys function. So I'll write my dictionary name, that is D dot, I'll give keys, close the brackets, and hit Shift Enter. You can see these are the list of my keys in the dictionary D. Alright. Okay. Now let's move to our next question. So our next question is, what do you mean by list comprehension in Python? So list comprehensions are a short and easy way to define and create new lists based on existing lists. So suppose you want to iterate through a list and find all the even numbers in the list, you can either use a for loop and an if condition as shown here, or you can write a list comprehension to do it in one line of code. You can see this is my list comprehension. So let me show you both the ways. Alright, so here on my Jupyter notebook, let me declare my list as L equal to, I'll pass in a few numbers, let's say 5, 12, 10, we have 14, 43, 11, 7, 9, and let's say the last element in the list is 6. Alright, let me run this list. Okay, now let me create an empty list, let's say list 1, and let this be an empty list with square brackets. Then I'll use the looping construct to find the even elements in the list. So I'll write a for loop called for item in my list L. I'll give colon, then I'll give my condition if item percentage 2 is equal to 0, which means if the remainder is 0, then I'll append the items to my empty list, which is list 1. So I'll write list 1 dot append, and I'll pass in the argument my item. Now let me go ahead and print my list. I'll write print the final list using a for loop. I'll give colon, give a comma, and pass in my new list name, which is list 1. Now let's run this. You can see using this for loop and the if condition, I have got all the even elements in my list, which was L. You can see my original list, and 12, 10, 14 and 6 were all the even numbers present in my list. Now this task, you can do it using list comprehensions as well. So let me show you how to do that. So I have my list defined. Let me just copy this here. I'll paste it. And now I'll create another variable which is list1. I'll write equal to. Now here, using square brackets, I'll write item for item in L, and I'll give my if condition as if item percentage 2 is equal to 0, then I'll print my resultant list. So I'll write print, let's say resultant list using list comprehension. I'll give a colon, then a comma, and I'll pass in my new list, which is list 1. So here, whatever is there in my square brackets is called the list comprehension technique. Let me just print this, and I'll get the same result. So these are my even numbers. Alright, so let's move to the third question. So our third question is, given a list of numbers, find the squares of the numbers using the map function in Python. Now the map function calls the specified function for each element of an iterable and returns a result. So let me show you an example to find out squares of a list of numbers using the map function. Okay, so let's first define a function called square. So I'm using my def keyword, and I'll pass in my user defined function name as square, and I'll give my parameter as x, and I want to return the square of x, which is x star x. Alright, and then let me define my list of numbers. So I'll pass in a variable called num, and let's say I want to find the squares of 5 numbers 1, 2, 3, 4, 5. Here I'll pass in another variable which will store the resultant list. So I'll write num underscore squared equal to, here I'll use my map function. So map function takes in two parameters. First it will take in the user defined function name, which is square here, and the list of numbers, which is num. I'll run a for loop. I'll write for, let me just scroll down. I'll write for num in num underscore squared print num. So this is my map function. So it will map all the elements in the list to this function, which is square. I'll just print it. You can see we have the list of squares from the num list, which has the elements 1, 2, 3, 4 and 5. Now moving ahead, coming to our fourth question. The fourth question is on to write a program that will filter out the numbers divisible by 3 from a tuple using the lambda functions. So lambda functions are anonymous functions that are not defined by the def keyword in Python. So here you can see I have the example. So this is a tuple I have defined, and using filter along with the lambda function I am trying to find out the numbers that are divisible by 3, and finally I am printing those numbers. So let's do it on our Jupyter notebook. Alright, so we are on the Jupyter notebook. So first I'll define a tuple. Let's say the variable name is my underscore tup, which stands for my tuple, and using brackets I'll pass in my tuple values. Let's say 5, 12, 10, 18. We have 43, 9, 7, 11 and let's say 6. So you can see these are the numbers present in my tuple. Now I'll create another variable called new tuple, and I'll use my tuple function, and inside the tuple function I'll use the filter function that will filter out only the values that are divisible by 3. And now I'll write my lambda function. So notice this clearly how to use a lambda function. I'll use the keyword lambda, and then I'll pass in a variable x. Now this should consider only those values that are divisible by 3. So I'll write x %3 should be equal to 0, and I'll give my tuple as the variable here. Alright, now we have declared our lambda function. Let's just go ahead and print my new tuple, which is new underscore tup. So here you can see I have my tuple function. Inside the tuple function I'll use my filter function that will filter only those values divisible by 3, and to filter those values I have used my lambda function here and passed in my original tuple, which is my tuple. It's actually my tup, so let's delete the last two letters. Let's just go ahead and print this. There you go. You can see we have 12, 18, 9 and 6 are the only numbers that are divisible by 3 from this tuple. Moving to the next question. So our next question is how to create a data frame from a dictionary. Now to create a data frame from a dictionary, you can use the pandas library and the .dataframe function. Now pandas is a popular library in Python that is used for data manipulation. So let me show you how you can create an employee dictionary and then convert that into a data frame. Okay, so here on my Jupyter notebook, let me go ahead and import my pandas library. So I'll write import pandas as pd, and next let's create my employee dictionary. So I'll write emp, which stands for employee, and within curly braces I'll give my key value pairs. So my first column would be the name of the employee, and let's pass in a list of employee names. I'll write Amy. Let's say we have Angela. The third employee's name, let's say we have Samuel, and let Danny be our fourth employee. I'll give a comma. Now the second attribute in our dictionary will be the age of the employee. So my key would be age, and let's create a list of age values. I'm assigning random values to those employee age, 30 and let's say 32. And let's create another variable called city. Here variable refers to the column name of the data frame. Let's say Amy is from New York. Then we have Angela from Chicago. Let's say Samuel is from Boston, and we have Danny from, let's say, Seattle. Okay, so if I run this, I have my employee dictionary created. So if you want to see the dictionary, you can write print and pass the variable name, which is emp here. So this is my dictionary. Now to convert this dictionary into a data frame, you can simply write df, and you can give the pandas library as pd and use the data frame function. So I'll write data frame, and I'll pass in my dictionary name, which is emp here. Let's run it. Okay, so we have successfully created our data frame. Now let me just print the data frame. I'll write df. There you go. You can see I have a nice table here, which is actually a data frame. Here you can see the indices, and you can see our column names as name, age and city, and these are the values or the rows. Alright. Now let's see the sixth question we have. So the question is, what is the difference between LOC and ILOC in Python? Now as data scientists, you would often want to analyze a chunk of data and not all the rows in it. So LOC and ILOC functions can help you fetch specific rows and columns from your data frame. Now, LOC function uses row or column labels to select and slice data from a data frame, while ILOC uses integer index to select specific rows and columns. Remember, ILOC stands for index location. I'll use a car data frame to show how LOC and ILOC works. Now on your screens you can see the data frame. So it has a column called brand, which has different brand names such as Ford, there's Hyundai, Tata, Mahindra, there's Maruti, there's Kia Motors. Then we have the year in which the car was manufactured. We have the number of kilometers the car has run. We have the city and the mileage the car gives. So let me first create this data frame on my Jupyter notebook. Okay, so here on my notepad I have my code written to create the data frame, that is car. I'll just copy this code and I'll paste it to this cell. Okay, let me just run it. So if I go on top, you can see we have successfully created our car data frame. Now let me go ahead and print this data frame. So I'll write print, in brackets I'll give my data frame as car. Let me run it. Alright, so here is my data frame. Now suppose you want to see the data from second row till the fifth row for brand and city columns, so you can use the LOC function. So I want my data from the second row till the fifth row for brand and city columns. So let me show you how to do that. So first I'll write my data frame name, that is car, and then I'll give my function as LOC, and within brackets I'll give my row index values. So I'll give from 2 to 5, which is second row to fifth row, and I'll give my column names as brand I'll give a comma, and my second column which I want is city. So here I'm using the labeled based indexing. Let me just run it. There you go. You can see we have the information available for the second row, third row, fourth row, and the fifth row. Alright. Similarly, let's see one more example for index location based slicing. So suppose you want to see the data from second, third, and fourth row for year, kilometers, and city columns. So for that you can use the ILOC function. So I want the value for second, third, and fourth row, and the columns that I want are years, kilometers, and the city column. So for that I'll give my data frame name as car dot, this time I'll use ILOC, and within square brackets I'll give my row values and the column values. Now one thing you should notice here is if you use ILOC, Python will exclude the last index, which is the fifth row, and similarly here it will exclude the last index from the column, which is the fourth column. If I run this, you get the desired result. Now let's see another example. Let's say this time I want to print the rows that have mileage less than 25 for brand and city columns. So you can use a print function, and I'll pass in my data frame as car and use LOC. Here I'll give my condition as car, and I want my condition that is mileage should be less than 25, and I want the brand name. So I'll use a square bracket and give my brand column, and I also want the city column. Okay, let me close it. If you run this, now these are the brand names Renault, Tata, and Kia, which have mileage less than 25. Let me just verify this. You can see all these values are less than 25. Similarly, you can use the ILOC function as well. I can write print. I'll give car dot ILOC. Within square brackets I'll give car, and my condition column is mileage. Now this should be less than 25. I'll use dot values, and then I'll give my column numbers as 0, 2. Let me run it. There you go. The same result, we have got it using ILOC function this time. And you can see the columns were 0, 2, which means we wanted the first column, which is brand, and the second column, which was kilometers. Alright. Now moving to our seventh question in the list of questions that we have. The question is, how is list.append different from list.extend? Now list.append adds its arguments as a single element to the end of the list. The length of the list increases by 1 here. And list.extend iterates over its arguments and adds each element to the list. The length of the list increases by the number of elements in its arguments. So let me show you the difference on my Jupyter notebook. Okay, so let's create a list called list1 equal to, I'll create a list, let's say it has some country names like India, then we have USA, and I'll consider one more country, let's say Canada. Okay, now let me print the length of this list also. I'll use the length function for that. Alright, now let me append one more list. So I'll use the append function. I'll write list1 dot append, and within brackets I'll give my new list which has two more country names, let's say France and Spain. Okay, and here let me print list1, and let's also print the length of the list again. I'll use the length function and my list name which is list1. So just mark we are using append here. Let me run this. There you go. So here you can see my original list had 3 elements, hence the length is 3. Now when I appended this new list which had 2 elements, France and Spain, our size increased by 1 and the length of the new list is 4. Now let me just copy this code, and instead of append let me write extend so that we can see the difference between append and extend. I'll just scroll down, run it. Here you can see our original list had 3 elements, but after we extended our list with 2 more elements, the length of the new list became 5. So these are the 5 elements in the list, and here you can see there were total 4 elements in the list when we appended the new list. Okay, now moving to our 8th question. Suppose you have a car dataset which has a mileage column. You need to create a new field called MLG that will accept 2 values. If mileage is less than 25, then the value should be low MLG, and if the mileage is greater than or equal to 25, then the mileage should be high MLG, or the value should be high MLG. Now while analyzing data, data scientists often need to create extra columns in the data frame to add more values that will help you make your data analysis more efficient. So this question is related to one such instance or one such idea. So here you can see my data set. It has the brand name, year, kilometers, city, and the mileage column. Now if mileage is less than 25, I'll add the value low MLG to my new column. Else, if mileage is greater than or equal to 25, I'll add high MLG to my new column. So here you can see my final output. Wherever the mileage is less than 25, it should print low MLG, else it should print high MLG. And now let's do this on my Jupyter notebook. So we'll use lambda functions that we learned earlier to perform this task. I'll write a function, let's say f is equal to, you can call this as a function or a variable. I'll give the keyword lambda and use x as my parameter. Now x should be low MLG if x is less than 25, which is mileage here, else if it's not less than 25, it should return high MLG. Now what I'll do is I'll give my data frame as car, and I'll create my new column, that is MLG. Then I'll write equal to car dot, I'll give my column name from the original data frame which is mileage, and I use my apply function and pass in the variable f. Now let's just print this data frame. If I run it, you can see the output here. We have created a new column which is MLG. You can see our new column name was MLG, and these are the results. So for Renault, Tata and Kia, for the last 3 rows, since the mileage is less than 25, it returned low MLG. For the remaining, it gave us high MLG. Now moving to the 9th question. So this is our next question. We want to create a 4x4 matrix and find the sum of all the diagonal elements in the matrix. Data scientists often work with multiple dimensional arrays or multi-dimensional arrays and matrices to build models. This question is related to an operation on a 4x4 matrix. So first, we need to create an array which will be a NumPy array of 4x4 shape, and then we'll see how to calculate the diagonal elements or the sum of the diagonal elements. So I am on my Jupyter notebook. First, let's import the NumPy library. So I'll write import NumPy or NumPy as np. Let me run it. Okay. Now I'll create my 4x4 matrix. So I'll write m is equal to np dot array, and I'll create my 4x4 matrix. Let's say the values are 1, 2, 3, 4 in the first row, and in the second row I'll pass 5, 6, 7, 8. In the third row we'll have 9, 10 and 11, also 12, and finally we'll have 13, 14, 15 and 16 in the fourth row. I'll just run it. Now if I print m, you can see this is a 4x4 matrix. So this is one way of creating a 4x4 matrix, which is a bit tedious and lengthy. Instead of that, you can also use arange function. So if I write m is equal to np dot arange function, and here I'll give my values starting from 1 till 17. So this will actually exclude 17 and take from 1 to 16, and I'll give my shape as 4, 4. Let me print it. There you go. It has printed the exact same matrix that we saw above. Alright. Now to print the diagonal elements, we'll use the diagonal function. So I'll write print m dot diagonal. Let me just run it. So 1, 6, 11 and 16 are my diagonal elements. You can see this matrix. 1, 6, 11 and 16 are my diagonal elements. Now to print the sum of all the diagonal elements, I'll use the sum function. So I'll write m dot diagonal. Along with that, I'll pass my sum function. If I run it, so the sum of 1, 6, 11 and 16 is 34. Okay, so coming to the last question on this interesting session on programming interview questions for data scientists. Our question is, given a vehicle data frame, find the average and maximum mileage of the vehicles using pandas. So here, data scientists use statistical measures to analyze their data, so it is important to have knowledge of the statistical functions in Python. Here is my vehicle data set, and for each brand of vehicle we want to find the average and the maximum mileage. So let me show you how to do it. Okay, so here on the notepad I have my code written to create the vehicle data frame. I'll just copy it and paste it on this cell. You can see we have the brand column, the year column, kilometers, city, mileage. Here you can see the different brand of vehicles. Let me just create this data frame first, and let me go ahead and print the vehicle data frame. So I'll write vehicle and run it. So here is the data frame. Now I want to find the average and maximum mileage for each of the brands. So for this we'll use the group by function and the aggregate function that is available in the pandas library of Python. So let me show you how to do it. I'll give a variable called result, and then I'll use my data frame name as vehicle, followed by the group by function. I'll write group by, and since I want to check for all the brands, so I'll group all the brand of vehicles. Then I'll use an aggregate function which is agg, and within curly braces I'll give my column as mileage. I'll give a colon and pass in mean, which is for average, and I'll use max to find the maximum mileage. Now let's print it. I'll write print. I'll give a message as the average and maximum mileage of vehicles. Let me just print the result. I'll run it. You can see it has resulted in an error. The reason is in vehicle the V is capital. Now if I run it, there you go. Here you can see on the left we have the brand names. We have Hyundai, there's Maruti and Tata, because those were the only 3 brand of vehicles we had. And for each brand you can see the mean mileage and the maximum mileage. For Maruti it was 26.33 and the maximum mileage is 28. Similarly you can see for Tata vehicle as well. SQL is a widely used language for querying data from databases. It allows you to store, retrieve, manipulate and update data present in the form of rows and columns. Data scientists often work with structured data that is stored in MySQL databases, Microsoft SQL servers, Oracle databases, or even NoSQL databases such as MongoDB. Today, we will look at a variety of SQL questions. We'll be using the MySQL database for our demo. Throughout the video, we'll be using MySQL Workbench and the MySQL command line to solve the SQL queries. Let me show you the database that we will be using for this demo and the tables we are going to use. Okay, so here I am on my SQL Workbench, and below you can see I have a local instance created. I'll just click on it. Now it's asking me to enter the password. I'll give my password and hit OK. Now this will take me to the SQL editor. Now this is the SQL Workbench. So let me first create a new SQL query file. Alright, so first and foremost, let me show you the databases we have. For that, I'll use the command show databases. If I hit tab, it will autocomplete. I'll give a semicolon and hit Control Enter to run this. There you go. Here you can see the list of databases that we already have, and from the list of databases we are going to use the SQL_IQ database. So to use this database, I'll write the command use SQL_IQ. I'll give a semicolon. I'll select this and I'll click on this execute button. If I run this, you can see now I'm using SQL_IQ database. Now if you want to see all the tables present in SQL_IQ database, we'll use the following command. So I'll write show tables. Now this will list all the tables present inside SQL_IQ database. If I run it, you can see here it has executed successfully and it has given us 7 rows, which means we have a total of 7 tables in this database. You can see there's an author table, there's a table called books, we have customers, email, employee, players and weather table. So all these tables we are going to use in the course of this video. Now if you want to have a look at the data present in one of the tables, you can just use the select statement. So I'll write select star from, let's say I want to see the data present inside the employee table, so I'll write employee. So this is my table name. I give a semicolon. If I select this, hit the execute button, there you go. It shows me that it has returned 6 rows and These are the column names. We have the name of the employee, the age of the employee, we have the employee's salary and the employee ID. So there are total 6 employees in the table. Alright, now I can do the same operations on my SQL command line as well. Now let me open the command line first. Okay, so this is the MySQL command line client. It is asking me to enter the password, so I'll give my password first. Alright, now here you can see I have come inside MySQL. Now the operations that we performed on the MySQL workbench, the same operations can be performed on the command line as well. So I'll write use SQL underscore IQ. I'll hit enter. You can see the message, it says database changed. Now if you want to display the tables present inside this database, I can use show tables command. I have to give a semicolon and hit enter. There you go. You can see the list of tables we have inside the database. Now if you want to have a look at the content of one of the tables, I can just write select star from, let's say, players. If I give a semicolon, hit enter, you can see the rows and columns in the dataset. Alright, and with that, let's move on to our first question on SQL. Okay, so our question is, what is the difference between where and having clause in SQL? So where clause is used to filter the records based on the specified condition, while the having clause is used to filter the records from groups based on specified conditions. You need not worry, we'll do the demo for where and having clause using the employee table. So where clause cannot have aggregate functions such as count, sum, min or maximum functions. Having clause can operate on aggregate functions. Now where clause is implemented on rows, while having clause is implemented on columns. Now let me show you an example of how a where clause is different from an having clause. So I'll take you to my MySQL workbench. Alright, so we are on the SQL workbench. So suppose I want to get the records of the employees whose age is greater than 30. For this I can use a where clause. So since I want to get the employees whose age is greater than 30, I'll use a where clause. I'll write my SQL query as select star from employee where I'll write age is greater than 30. If I give a semicolon and run this, it will return all the employees whose age is greater than 30. You can see 36, 36 and 35. These are the employees whose age is greater than 30. Now I have intentionally kept some duplicate rows because we are going to use this in our next questions. Again, I can also do the same task using the having clause. So let me just copy this query. I'll paste it here. Now instead of where, I'll write having. So you will see that even this query will return the same result. If I run it, you can see it gives me the same result. Now let's say I want to find all the records where the count of age for all the employees is greater than 1. In this case, I can't use a where clause. It will throw me an error since where clause cannot be used with aggregate functions. So let's try using an aggregate function in the where clause. So I'll write select star from employee where count of age is greater than 1. So the idea is to find all the records where the count of age for all the employees is greater than 1. So if I run this SQL query, you can see it has given me an error. It says invalid use of group function. Now instead we need to use a having clause along with the group by clause to solve the problem. So I'll group all the age values and then find the count of each age value. So let me just paste this, and here I'll edit my SQL query. Instead of where, I'll write having, and just after the table name I'll use the group by clause. So I'll write group by age. Now let's run it. Alright, you can see our SQL query has returned only those employees whose age occurs more than once. Now let me just verify this. If I run my employee table, you can see Angela's age, that is 36, has been repeated twice. You can see Angela here as well, and similarly we have Mike also repeated twice. Alright. Now let's see the second question. Now this is a multiple choice question where you need to answer the correct SQL query based on the question. So the question is, the correct SQL query to select all the records of employees with ARI in their names is. So we have a list of 4 options given, and out of that you need to find the correct option. Now the answer to this question is this. So if you write select star from the table name, which is employee here, where name like, then if you give this condition, it will return all the records where employees have ARI in their names. Now like is an operator in SQL that is used to search a specified pattern. So here our pattern is we want all those employees who have ARI in their names. The first percentage means that the name can have any number of letters in the beginning, followed by ARI in the middle, and the last percentage means the name can have any number of letters in the end. So let's do this on our MySQL workbench. Let me first display all the employees in the table. So I'll write select star from employee. I'll run this. If you see my table, I have one employee who has ARI in its name, and that person is Karin. I now want to get this particular record. So what I can do is I'll write a select query, select star from employee where name, then I'll use the like operator where name like, within double quotes I'll give percentage ARI, again a percentage, close the double quotes and give a semicolon. If I run this, you can see my SQL query will return only Karin. Now let's do one more example. Suppose I want to find the employee whose name starts with D. So the way to do is something similar to what we saw just now. So here in my condition, I'll just replace this with D. This means the name should start with D, and after that it can contain any number of letters. Now let's run it. There you go. So our table had one employee called Danny whose name started with D. Now moving to our third question. So the question is, we want to write a query to find the players with the least number of goals. So there are 2 methods to do it. One where you can use a subquery, and the other method to use the limit operator. So let me show you both the methods. First, let me go ahead and display all the tables present in my database, that is SQL or SQL_IQ. Alright, if I scroll down, you can see we have a table called players. So I'm going to use the players table to find the player with the least number of goals. So let me show you the first method, that is by using a subquery. So I'll write select star from my table name, which is players, where goals equal to, and in this I'll write my subquery using brackets. So I'll select minimum goals from the table that is players, I'll close the bracket and then I'll give a semicolon. Now let me go ahead and run this. You can see Matt was the player from Scotland who scored the least number of goals, that is 3. Now let's break it down. So what we did was,